Hey everyone, I already discussed how to find functional dependency closure and attribute closure. Next I will discuss cascading delete. If by deleting one attribute we are deleting another attribute, then that is called as cascading delete. Suppose we are deleting one attribute from the primary key, and if there is any foreign key that is dependent on that primary key, that also we need to delete. Cascade delete is a database constraint for foreign key relationship that automatically delete associated record in the child table when corresponding record in the parent table is also deleted. As foreign key is dependent on primary key, if we are deleting primary key, we also need to delete the foreign key. Let's see one example that you can understand. Here B is the foreign key, A is the primary key, B is dependent on A. And we have some attributes like 1, 1, 1 for A, 1 for B. This is our primary, this is our foreign key. Then 2, 1, 3, 1, 4, 2, 5, 3, 6, 4, 7, 6, 8, 6, 9, 7. Now suppose we will delete 4, 2. Okay? 2 from B, 4 from A. As we are deleting 4 from A, so there is no existence of 4 as a primary key, so 4 cannot be in foreign key. We need to delete 6, 4. As we are deleting 6 now, so we need to delete 7, 6, 8, 6 as 6 are the foreign key. As we delete 7, so we need to delete 9, 7. After deleting 4, 2, we need to delete 6, 4, 7, 6, 8, 6 and 9, 7 as these are dependent. So this is a cascading delete. After deletion of one functional dependency, we need to delete multiple functional dependency as these are dependent. When we are deleting one primary key, we should delete the foreign key that is dependent on it. Next I will discuss equivalence of functional dependency. If two set of functional dependency is given and one set of functional dependency we can find from other functional dependency, then we can say this is a equivalence of functional dependency. So in functional dependency, let F and G will be equivalent if F positive closure and G positive closure, and F we can find from G and G we can find from F. Let's see one example. We have two functional dependency sets, F and G. Now we'll check F in G and G in F. A implies C, that we'll check by finding A positive closure from G. So A positive closure equals to ACD. Here C is at right side, hence this satisfied. Next AC derived D. So AC positive closure from G, that will be again ACD. There is D at right side, hence it also satisfied. Then E derived AD. For that we need to find positive closure of E from G. So E positive closure will be EAH. Again from A we can derive C and D. So EACDH. Now there is A and D, hence E implies AD also hold from G. Next E implies H. E implies H also hold as H is at right side. Next we need to check A implies CD from F. So A positive closure will be AC, then from AC D. CD is at right side, hence this hold. Next E derive AH from F. E positive closure from F, that will be EAD. From this implication also H, as E implies H, then from A, C and D. So EACDH. And here AH are at right side, hence it hold. We can derive F from G and G from F, hence both functional dependency are equivalent. Let's say another example, example 2. Here we have two functional dependency set F and G. We need to check same way F from G and G from F. So B positive closure from G, that will be B, C, D, E. Then here A, B, C, so you can add A, B, C, D, E. So B positive closure will be all A, B, C, D, E. Here C, D at right side, hence B implies CD hold. A is at right side, B implies A hold. So B implies CD and B implies A hold. Next we'll check AD implies E from G. So AD positive closure, that will be A, D, E. E is at right side, hence it hold, right? Next we'll check G from F. So B positive closure from F. It will be B, C, D, then A as B implies A, then from A and D, E. Okay. So C, D are present at right side, hence it hold. A, B, C are present at right side, hence B implies A, B, C also hold. Now both these dependency hold. Next we'll check AD implies E. So AD positive closure, that will be A, D, E from F. Okay. So A, D, E. E is at right side, hence it hold. We can find F from G and G from F, hence both the functional dependency are equivalent. This is one application of functional dependency closure. We can check whether two functional dependency are equivalent or not by checking the functional dependency closure. Next we will discuss some basics of relational model. A relation is a table with columns and row. Each column are for attribute and each rows are for tuple, and a domain is a set of allowable value, means what constraint we can add for the domain, whether it should be numeric, whether it should be alphabetic, that is the domain. And degree of a relation is the number of attribute that it contains. Remember, degree is number of attribute and cardinality is number of tuple. So number of column or number of attribute, that is degree, number of rows or number of tuple, that is cardinality. Once this was asked in question, what is degree of a relation? Degree of a relation is number of attribute in that relation. And cardinality of a relation is the number of tuple in that relation. A relational database is a collection of normalized relation. It is a collection of multiple relation and each relation should be normalized. The intention of relation is the structure of relation including its domain, and the extension of the relation is the set of tuple currently in the relation. If it is asking what is intention, intention is the structure and extension, the set of tuple that currently it hold. Next is normalization. Normalization is a process by which we split a relation into multiple relations according to some properties. There are different steps of normalization like 1NF, 2NF, 3NF, 4NF, BCNF. So in each NF, we'll split the table into multiple table. We'll split the relation into multiple relation. So basically it is a process of reducing redundancy by eliminating insertion, deletion and modification problem. It's called as normalization, or you can say it is a evaluation tool for logical database design in terms of insertion, deletion and modification. Normalization have several advantages, also several disadvantages. Advantage is we can separate the table, we can simplify the table, it will be easy for insertion, deletion and modification. But this continuously splitting, continuously decomposition of relation sometimes lost the data. Okay, that is a disadvantage. So we need to do normalization in such a way that we will not lose the data, not lose the dependency. I'll discuss detail about lossless decomposition, lossy decomposition. So it should not be lossy, it should be lossless. In next lecture, I will discuss first normalization. In today's lecture, I discussed what is cascading delete, equivalence of functional dependency and some basics relational model definitions. If today's lecture is helpful for you, please like, share and subscribe. Thank you. Bye-bye.